There is a flower that grows in the filthiest places on Earth. Swamps, sewage ponds, stagnant water thick with algae and bacteria. The kind of place where everything else gets coated in slime. And yet, it remains absolutely spotless. In 1997, a German botanist stared at this flower, and he wasn't thinking about spirituality. He was thinking about money, because he just discovered the secret to perpetual cleanliness, a mechanism so simple that today it's worth $50 billion. It's in the paint on your walls, the coating on your phone, the glass on skyscrapers, even inside hospitals, saving lives. I'm Carl, and I hunt for nature's patents, the billion-dollar secrets hiding in plain sight. Today, we're decoding how a leaf became the foundation of modern materials science. This is the story of the lotus. 1973, University of Bonn, Germany. A young botanist is doing something his colleagues think is pointless. Wilhelm Barthlott is putting plants under an electron microscope, thousands of them. Oak leaves, rose petals, cactus skin. Most scientists called it tedious. Barthlott called it fascinating. And over 20 years, he noticed something impossible. The cleanest leaves weren't the smooth ones. They were the roughest. Now this broke every rule we had. We polish marble. We wax cars. We buff hospital floors. Smooth equals clean. Right? Wrong. In 1997, Barthlott published his findings. The plant with the most extraordinary self-cleaning ability? The sacred lotus. Watch what happens when it rains. Water doesn't spread. It doesn't soak in. It forms perfect spheres. And as those spheres roll off, they collect every speck of dirt, every bacteria, like a microscopic vacuum. The leaf cleans itself. Barthlott called it the Lotus Effect. He had no idea. He just described the future of everything we build. So what makes this leaf impossibly clean? The answer exists at a scale most people have never seen. The nanoscale, 1/1000th of a meter. Under an electron microscope, the smooth leaf surface reveals itself as a mountain range. Tiny peaks about 1/10 the width of a human hair. But zoom in further. Each peak is covered in even smaller structures, nanocrystals of hydrophobic wax. Think of it like this. Imagine trying to sit on a bed of nails. You don't sink down, you rest on the tips. Water molecules do the same thing. They balance on the tips of these nanocrystals. Minimum contact, maximum repulsion. On normal surfaces, water spreads out. Contact angle, maybe 60 degrees. On glass, 70. On waxed car paint, 90. On a lotus leaf, 160 degrees. The water literally cannot touch the surface. It can only ball up and roll away. But here's the genius part. The Lotus doesn't just repel dirt, it uses water as a cleaning tool. The droplet has such high surface tension, it acts like sticky tape. Dirt particles sitting loosely on those nanopeaks, they stick to the water. They get carried away. The leaf doesn't fight dirt. It uses rain to take out its own trash. That's not just smart, that's elegant. Once we understood the mechanism, the question became, can we replicate this? It seemed impossible. Creating structures at the nanometer scale, billions of them, on massive surfaces. Paint companies had tried for decades to make stay-clean coatings. They all failed. Dirt always wins. You always need pressure washers, chemicals, labor. But Barthlott's paper changed everything, because now we knew exactly what to copy. You need two ingredients: roughness at the nanoscale and a hydrophobic material. Get both right, and physics does the rest. In 1999, just 2 years after the paper, the German company Stow launched something revolutionary: the world's first commercial Lotus Effect paint. Lotusan. The paint contains billions of tiny silicon particles mixed with hydrophobic polymers. When it dries, these particles self-assemble into a rough, nano-textured surface, just like the lotus leaf. Artificial biomimicry at the molecular level. Let me show you the difference. Normal paint. Rain hits. Water soaks in. Dirt dissolves, penetrates the pores. Algae grows. Mold spreads. The building gets stained. You call a pressure washing company. Hundreds of dollars. Harsh chemicals. The paint surface gets damaged. Repeat next year. Lotus Effect paint. Rain hits. Water beads up. Rolls off. Takes dirt with it. The building cleans itself. No chemicals. No labor. No damage. Just rain. Today, the Lotus Effect is everywhere. And it's not just about clean walls. It's about saving lives and saving money. Architecture. The Marina Bay Financial Center in Singapore. Tropical humidity. Daily storms. Extreme pollution. Normal buildings turn green with algae within months. But with biomimetic coatings, 10 years almost, no cleaning. Maintenance costs down 70%. Visual, massive solar farm. Solar energy. Solar panels lose efficiency when dusty. In deserts like Arizona or Saudi Arabia, dust is constant. Workers clean millions of panels every week. Expensive and wastes precious water. But panels with Lotus coatings? Rain cleans them automatically. Efficiency improvements 15 to 20%. Over 25 years, millions of dollars in extra electricity. From a coating inspired by a leaf. Medical devices. Now this one might save your life. Hospital-acquired infections kill 99,000 people in the U.S. every year. Many infections come from bacteria colonizing medical equipment. The CDC estimates these infections cost the U.S. healthcare system $28 billion annually. But bacteria need moisture to attach and multiply. If the surface is super hydrophobic, water can't stay. Bacteria can't colonize. Surgical instruments, catheters, implants coated with Lotus technology show 50 to 70% reductions in bacterial adhesion. Think about that. A coating inspired by a flower growing in a swamp is making operating rooms safer. That's beautiful irony. Automotive. That coating on your windshield that makes rain fly off? Lotus Effect. Better visibility, safer driving, fewer accidents. Consumer electronics. Your phone screen. That coating that repels fingerprints and makes water bead up? Lotus Effect. Aviation. Ice on wings is deadly. Experimental Lotus coatings prevent ice adhesion passively. No power, no chemicals, just physics. Let's talk money, because this is where it gets really interesting. In 1997, the global specialty coatings market was $8 billion. By 2026, $53 billion. The fastest growing segment? Self-cleaning bio-inspired coatings, growing at 12% per year. The property value case. A study by the National Association of Realtors found that homes with low-maintenance exteriors sell for 8 to 12% more. On a $500,000 home, that's $40,000 to $60,000 in added value. Lotus Effect paint costs an extra $2,000 to $3,000 for a full exterior. The ROI? 1,300%. The investment opportunity. Companies specializing in bio-inspired coatings have seen stock prices rise 340% since 2020. Major players like BASF, PPG, Sherwin-Williams have all launched biomimetic product lines. And with patents expiring, smaller innovators are entering the market. Competition drives prices down and quality up. This isn't just cool science. It's a competitive advantage. Biomimicry is profitable. Here's a thought that humbles me. Humans have practiced chemistry for maybe 200 years. Modern materials science? 70 years. The Lotus has been perfecting this technology for 300 million years. We didn't invent self-cleaning surfaces. We discovered them. And here's what fascinates me. Every organism is a walking patent portfolio. Billions of years of research and development. Zero waste, perfect efficiency, completely sustainable. The biomimicry revolution isn't about saving nature. It's about learning from nature. Because every species holds solutions to problems we're trying to solve right now. What cancer treatment is hiding in a rainforest compound? What energy breakthrough exists in a bacterial genome? What material revolution is encoded in deep-sea creatures? I don't study nature because I'm an environmentalist. I study it because it's the greatest engineering library ever written. And we're finally smart enough to read it. So where does this go next? Imagine a city where buildings never need cleaning, where roads shed ice automatically, where hospital surfaces cannot harbor bacteria, where your clothes repel every stain. We're already working on it. Researchers at MIT have created 3D printable surfaces with programmable Lotus properties. Scientists in Switzerland developed coatings that are self-healing. Scratch them, they repair themselves using ambient moisture. Companies in Japan are testing Lotus Effect concrete for sidewalks that never stain. The question isn't, can we do this? We can. The question is, what else is nature ready to teach us? If this fascinates you, there's a field waiting. Biomimicry engineering is one of the fastest growing careers in science. But you don't need a PhD to apply this thinking. Every video I make, I ask myself, what would nature do? Nature doesn't waste energy fighting problems. It uses elegant systems. The lotus doesn't repel dirt with force. It uses rain as a partner. That mindset changes everything. In business, in design, in life. This field is called biomimicry. And I've been hunting nature's patents for years. We've covered kingfishers that taught bullet trains to be silent, owls that taught stealth bombers to disappear, and now the lotus, teaching us perpetual cleanliness. Next time, how a gecko's foot is revolutionizing adhesives, robotics, and space exploration. NASA is using this to build climbing robots for the moon. And it all started with a lizard walking up a wall. The future isn't purely artificial. It's biological. Nature invented it first. And I'm here to decode it for you. I'm Carl. This is Nature's Patent. If you want to see what else nature's been hiding, hit subscribe. I release a new patent every 2 weeks. Drop a comment. What should I decode next? I read every single one. See you at the next discovery.